Alright, so today we're going to go ahead and go over the study guide for the Unit 3, Topics 3 and 4 review. And I'm going to go ahead and start off in the first section here, which is about trig equations. And so for this first problem, they're asking me to solve, cosine of 3x equal to root 2 over 2. And then they give me the stipulation that x has to be between 0 and 2 pi, including 0 and 2 pi. And so I'm actually going to do this in kind of two steps here. The first step, I'm going to solve just cosine of x equal to root 2 over 2. Okay, so if you go to your unit circle, you'll see that there are two values, or two angles that make this true. One is pi over 4, which is in quadrant 1 where cosine is positive, and then also in quadrant 4 we have another angle, 7 pi over 4. Okay, so now I'm going to write down a second piece of information related to the period. And if you remember from when we did graphing with trig functions, we said the period formula for sine and cosine is 2 pi over the absolute value of b, okay, where b in this case is 3. Okay, so here I'm going to have 2 pi over 3, and 3 is already positive, so we just kind of forget about the absolute value. So there's our period. We're going to come back to why that's important. And now what I need to do here is, I solved this equation, right, but I didn't include the 3 here. So now I need to kind of update these answers here with the 3 on this side because of this 3 here. Okay, so that's what I'm going to do down here. So I'm going to say 3x equals pi over 4, and 3x equals 7 pi over 4, okay? And then I'm just going to solve for x by dividing by 3, which is equivalent to multiplying by a third. So I get pi over 12. And then on this side, I get 7 pi over 12. So those are two of our answers. I'm just going to kind of make a running list here of our answers. Okay, and now something interesting happens that I have to kind of pay attention to. The interval that I'm supposed to solve is between 0 and 2 pi. 7 pi over 2 is just past pi over 2, right? Because 6 pi over 12 would give me equivalency of pi over 2. So the point is that I'm missing some answers here. And so what I'm going to do is I'm going to use the period that I have here to find additional answers that I'm missing. Okay, so I'm going to do that on the next page. So what I'm going to do is I'm going to take pi over 12, my first answer, and I'm going to add an increment of the period. Okay, remember that you need an LCD here, so I'm going to multiply this guy by 4 over 4. Okay, so that I have pi over 12 plus 8 pi over 12, which is 9 pi over 12, which itself can simplify to 3 pi over 4. So there's another answer. And then I'm going to do the same thing for my second answer, which was 7 pi over 12. Add an increment of 2 pi over 3, which is the period. Okay. And I have a similar, or the exact same process really, right? But now there's a 7. So that gives me 15 pi over 12, which simplifies to 5 pi over 4. So now I have these two answers that I can add to my answer list. So I'm going to add 3 pi over 4 and 5 pi over 4 to my answers. And now if we kind of reevaluate where we're at, 5 pi over 4 is more than pi, so I still have room to find more answers, right? Because I can go all the way up to 2 pi. Okay, so now I'm just going to repeat the same process, but now I take 3 pi over 4, it's a pi symbol there, sorry, and add another increment of the period. LCD is still 12, so I'm going to multiply this one by 3 over 3, this one by 4 over 4. So I get 9 pi over 12, right, plus 8 pi over 12, which gives me 17 pi over 12, which can't be simplified. So there's another answer. And now, so I just did this one, I'm going to do 5 pi over 4. So I have 5 pi over 4 plus 2 pi over 3. Okay. 5 pi over 4, I can multiply by 3 over 3 and get 15 pi over 12. The 2 pi over 3 is equivalent to 8 pi over 12, as we've been seeing. So this gives me my final answer, 23 pi over 12. And the reason that I know that's my final answer is because once I get to 24 pi over 12, well, that's 2 pi, right? And I cannot go above 2 pi, right? So if I add any more increments of the period, I go over. So now I can add, let's see what they were, 17 pi over 12. Oops, let me get my pen here. 17 pi over 12 and 23 pi over 12, right? So those are my final, in this case, 6 answers, right? And again, if I go any further, I go past the 2 pi, which I'm not allowed to do based on the interval they've given me. Okay, so there's your first problem in section 1. I'm going to go ahead and start on the second problem, which is dealing with the tangent. So here's the second problem. Okay, so here they're asking us to solve. Let me write that a little nicer. They're asking us to solve an equation that involves tangent now, right? So I'm going to do the same process, but I need to change the period formula once we get that far, right? So if we revisit where we've been, we go back here. First step, I kind of simplify the equation. Okay, so that's what I'm going to do here. I'm going to say, first, just find tangent of just x, not x over 2. And where is that equal to negative root 3, right? So if you go to your unit circle, tangent is negative in quadrants 2 and 4. So if I actually kind of try some out, or if I'm more familiar with the unit circle, which hopefully we are by now, I'll see that x equals 5 pi over 6 is one answer, okay? Because if you go to 5 pi over 6 and you divide the y and the x value, you'll see that you get negative root 3, which is what I wanted. Okay, and then directly diagonal to that in quadrant 4 is 11 pi over 6. Okay, so again, I've kind of simplified the equation first, and now I'm going to do this period kind of calculation here, but I need to be very careful because tangent has a different formula for its period, if you recall. So for tangent, whereas cosine's period was 2 pi over the absolute value of b, right? And which is the same for sine as well. Okay. For tangent, it changes to just pi over the absolute value of b, right? So in this case, again, it's pi over the absolute value of b, but I also have to notice that my b value is actually 1/2, right? There's a 1/2 there in front of the x, so that is my b value. B is 1/2, right? So if I plug that into this formula, I have pi, 1/2 is already positive, so pi divided by 1/2 multiplied by the reciprocal of 1/2, and you get the period is 2 pi, right? So now comparing to the previous problem, I just finished this step. Now I need to take these equations and kind of update them. Well, really these equations and update them, right? So I'm going to do that down here. So now I have, well, it's not just x, it's x over 2, right? That's what the original problem up here had. So x over 2 equals 5 pi over 6, and x over 2 equals 11 pi over 6, right? So I'm going to multiply by 2 on this side and this side. So here I get 10 pi over 6, which is equivalent to 5 pi over 3. Multiply by 2 here and here. So I get 22 pi over 6, which is equivalent to 11 pi over 3. And now something kind of interesting happens here. I'm actually not going to end up using the period because if you notice, this answer is past our interval, right? So we still have the stipulation that x is between 0 and 2 pi. Well, 11 pi over 3, that's almost equal to 4 pi, right? So I'm way past this 2 pi. And so my only answer for this question will be 5 pi over 3. Okay, so there is your first section of trig equations, and I'm going to move right along to section 2, which is asking us to verify specific identities. Okay. And we're going to use definitions and other identities that we know to show these are true. So remember, for these types of problems, your goal is to show that this side is equivalent to this side. Usually you go from the left to the right. It's a lot more difficult to show that secant is equivalent to this, but this I can simplify to get to secant a little bit easier. So one thing you want to do here, again, is you want to use your definitions. For example, cosecant we know is equivalent to 1 over sine. And then I'm actually going to write tangent in terms of sine and cosine, which is pretty much the most frequent strategy you'll use for these. Because if you notice, there's no tangent or cotangents over here. Everything is in terms of, in this case, secant, which is related to cosine. So I'm going to write tangent in terms of sine and cosine. And when you do that, you see this nice cancellation happen with the sine. So I'm left with 1 over cosine, right? Well, that's exactly the definition of secant of x, which is what I wanted to show, right? So that one I'm done already, okay? So we're going to go ahead and keep moving here and move on to letter B, okay, which is cotangent of x times tangent of negative x is equal to -1. So that's what they're claiming, and I need to show that that's true. So here I'm going to use the fact that I know tangent of negative x, and you can find the following fact on your formula sheet, is actually equal to negative tangent of x, right? Which is actually telling me that tangent is odd, if you remember us going over this. So I'm going to use this fact up here, and again I'm going to write cotangent in terms of cosine and sine, just like I will with tangent, okay? But before I do this tangent, remember tangent of negative x is equivalent to negative tangent of x. So this negative sign I can pull out front here, right? And then write just what tangent is, which is sine, that's an x there, over cosine, right? And then if you look here, we have a lot of nice cancellations. So I'm left with -1 over 1, which is -1, which is what I wanted to show. So I'm done again with that one. Okay, so there's letter B. Let's go ahead and move on to letter C. So we have cosine of pi over 2 minus x times cotangent of x is equal to, they want us to show that that's equal to cosine of x, right? So for this one, I'm going to use the what's called a cofunction identity, which again is also on your formula sheet. And that says that cosine of pi over 2 minus x is equivalent to sine of x, right? So here I'm going to use this fact right away, and I'm going to write cosine of pi over 2 minus x as just sine of x, okay? And then I'm going to write cotangent of x as cosine over sine, just like we did in the last problem. Okay, another common strategy again with cotangent and tangent. You see that the signs cancel, so I'm left just with cosine of x, and then I'm done, because that's exactly what they wanted me to show was true, right? Okay, so there's letter C for you. And let's move on to the last one of the trig identities, verifying each identity section, section 2. We're going to end off with letter D, and we'll stop this video with this one, and we'll do the other side of the review sheet in the next video. So this time they want me to show this is true, right? So there's a few things going on here. I'm going to use 2 facts that I know related to being even and odd. So if you remember when we talked about tangent, we said tangent was odd. This is true, right? Well, there are similar identities or properties for sine and cosine. It is also true that cosine of negative x is equal to actually just cosine of x, which is telling me that cosine is even, right? And then for sine, sine behaves similarly to tangent in the sense that it is also, whoops, actually I wrote tangent there. It is also odd. So that negative sign you can pull out, right? So sine is odd, just like tangent is, right? So I'm going to use these right away. I'm going to write cosine of negative x, according to this property, is equal to cosine of x. sine of negative x is odd. Sine is odd, so I can pull the negative out here. So I'm going to pull the negative out and put it right here. Right? And then if you notice, this is exactly the definition of cotangent with a negative sign, right? Which is what I wanted to show again. So there, I am done with the last verifying of identity, okay? So again, in the next video, we're going to continue with sections 3 and 4, and we'll wrap it up there, okay? Thanks for watching.